Green Neighbors is here to provide information and support for sustainable living and residential waste reduction. We are so excited to have Pierce as our guest speaker tonight. He is a co-founder at Dirt Hugger, a commercial composting company located in Dallasport, Washington. At Dirt Hugger, Pierce serves as the Swiss Army knife, focusing on business development, marketing, and finance, but leaves time to run loaders and screen compost. He is currently serving as the board vice president for the U.S. Composting Council.
So just a quick overview of what I'll talk about tonight. So kind of three parts. One is just a background and overview to kind of help you understand Dirt Hugger and who we are and how we started. Number two, the facility and process. So what we do at our site. And then lastly, talk about our products and kind of its different uses in different markets and where it goes into. And we'll look at some lab data and stuff like that. So we're, out here across from the Dalles. And it's about 90 miles from Vancouver. And the real key and really the reason that we got into business in the first place was keeping food waste out of the landfill. That's the real kicker environmentally, because food waste in the landfill decomposes anaerobically, right? There's no oxygen in the landfill. So that creates methane. That's 23 times worse than carbon dioxide. So really keeping that food waste out is the big kicker. And it turns out the transportation piece, so that 90 miles we're going, is less than 5% of the emissions that comes from food waste decomposition. So we really try to fill every truck we can going back towards the city with compost so that we really optimize the trucking and logistics and minimize that carbon footprint from the hauling out and back. And a truck that typically comes from Vancouver, so the truck that goes around to your house we would call that a route truck. So that's, your hopefully friendly garbage person. And then they'll tip it into their truck, and then they dump all of their trucks into a larger one, and the larger one comes out to us. And that's about a 28-ton truck. And then they pull around to here. So our newest, freshest material is downwind. It's to the east of our site. And then as material gets processed, it moves its way up the facility, upwind, until our finished product is the highest upwind. It's actually the highest in elevation, because what we don't want is cross-contamination coming across the site. So I don't want weed seeds that might have come in from somebody's yard debris bin blowing into the finished product. So everything travels its way upwind so that we don't have any cross-contamination. So this right here is a great example of probably stuff that came in that day. So the big trucks will come in, they'll dump in a pile here, and then we pile it all up and we cover it with compost. We put a 12-inch layer, so a 1-foot layer. It's called a bio cover of compost over. And what that does is it traps odors. It reduces vectors, so birds or squirrels or anything, they don't want to, the food's not exposed, so they won't want to eat it. And it just kind of encapsulates that. And we let that sit for a while, up to about a month. And then we put it through our pre-processing system. So you'll see, we'll look at some detailed pictures of what's happening there. But just so we get an overview, new material comes here, then it goes into this pre-processing. We do recipes and blending. We'll talk a lot about that. And then it goes on to this. This is the other real cornerstone of our site. It's called an air pad. So basically it's a giant air hockey table. So this is, at this point, it's 2 acres big, and it's got air holes every 5 feet on a grid in the floor. And we'll talk about how that aeration affects the process and affects the microbes, but that's a real key part of our facility. And we're one of the first facilities to have that in the region. So we love that. And then the other thing that's really cool about that is when we poured all these pipes in the ground back in 2015. And one thing we knew there was a lot of heat coming off the compost, and we didn't really know what to do with it, but we knew that it would be valuable. And so at the time, we put in 5,000 feet of radiant PEX tubing, like you might have if you had radiant floor heating in your house. And then a few years later, when we built the shop, we finally moved out of trailers, which was amazing, into a shop. We put that same tubing into the floor of the shop. So our entire building is now heated by compost. And then actually, right at the end of last year, we filled this roof with solar panels. So now the building's a net zero energy building. And we're super excited that the building's actually producing a little more energy than it consumes. So that we're pumped about that. Anyways, just looking at the overview. So material Once the recipe's built, and we'll go through this, it goes onto this air pad. It spends 1 month on this air pad, and it gets turned twice a week. So every Monday and every Thursday, this pad gets turned. And again, it's moving upwind. So it gets turned slowly this direction over the course of a month. And then we'll go through this. It goes through a pathogen reduction phase. So we're keeping the temperatures high to kill any pathogens. And once it's been through that, so on this air pad, we say, okay, it's done. It comes out here to the curing area where it sits for another 2 weeks to a month. And then it also keeps getting moved. It gets turned every Wednesday until it gets up here to this is the screener where we have finished product storage before it gets loaded and leaves. So, a truck will come in, dump material, get cleaned out, drive around the site, come over here, get loaded out, and then go back to where it came from. So that's kind of like a total overview of the system. And one thing that's happened over time, when we first started and we didn't have much technology or aeration, we were on a 163-day throughput cycle. So from getting raw material to making a finished product. And now we can do that in about 45 days because we're optimizing the environment for the microbes. So this area here, great question. That is it's called a leachate pond, but in Washington State, and this is unique to Washington, every drop of rain that touches our facility has to be captured. So we're a zero discharge site. So we have impervious surface everywhere, and it all drains to this little point right here. It's the lowest point on the site. And this is a sediment trap. So it drops out any of the solids, and then it goes into this pond, which is a high air pond, and that pond, which is a low air pond. And so we capture, all that water, and then we recycle it back into the process because we can, in the summer, we'll go through about 20 to 30,000 gallons of water a day. So we need all the water we can get. And we'll see in a minute, but we actually take in a lot of liquid feedstocks from breweries and other places that can't discharge their water. So our order of priority is we try to use first and foremost liquids that are coming in from breweries. And then secondly, we would use this water from the pond. And then our third priority would be using, this is a freshwater pond. It's about 100,000 gallons, would be using that. And the other thing, and it's good to see at this view, is we can use the beer waste here. We can use the leachate water here. But once we've been through this pathogen phase and killed the pathogens here, we can't add that water anymore. So out here, we can only use fresh water because we're not allowed to introduce any more pathogenous materials into the process at that stage. When you get the recipe right, so when we mix the right ingredients and get the right carbon to nitrogen ratio, the thermophilic microbes heat the pile up. And actually what we're doing here is we're trying to cool the piles because with the size of these piles, they actually will get way too hot. So within 24 hours, they would be above 180 degrees. And anything above about 165 or 170 starts killing off all of the good microbiology. So what we're doing with this air system is we're actually blowing off, it's evaporative cooling. We're blowing off the heat and we cool the piles down to, we have it set right now at 145. And that keeps us comfortably above the 131 required to kill pathogens. But if I didn't have to worry about pathogen reduction, we'd like to be at about 110 or 120 because that's a mesophilic microbe range, and they're way more efficient at decomposing the process. So 145 is a nice balance for us also between consuming water, because if we try to cool too much more than that, especially in the summer in Dallasport, we just can't keep up on the water. So the ideal temperature is 55% moisture. And actually, we send all of our operators. Washington State has a really cool training course, and it's a week-long course. We send everybody who runs a front loader or does anything out there goes to this course for a week. And one of the things they teach you is this hand squeeze test. And a well-trained person can be within like 3% of a lab in terms of sensing it. So really, you grab it, and then if it drips, it's too wet. If you open it up and it all falls apart, it's too dry. What we want is it to clump and then leave like a little bit of a sheen on your hand or your glove. And that's that sort of 55% moisture. And the key thing is if it's too wet, it locks it all up and it goes anaerobic. So the microbes can't move, and you can smell it pretty quickly if it's gone anaerobic. If it's too dry, which is kind of common at some compost facilities, you look at the pile and you're like, oh, it looks like a big pile of compost. But the microbes travel on the water molecules on like this water film layer around the material. And if it's not wet enough, they can't travel and they can't move. So they basically like, you've deflated their tires and they can't go anywhere. So hitting that moisture perfectly is really important. And I'll show you some equipment we have that we, at every stage, we're always adding water or tweaking water. And all of our operators are squeezing and looking and testing, because if above 65%, it doesn't work. And if you're below 45%, it doesn't work. So there's a band of about, 20% moisture, but staying at 55 is really nice. Some of the things we were just talking about. So when we get feedstocks in, we actually send them to the lab quite frequently to understand what their carbon to nitrogen ratios are. So we want to know what they are, basically like what kind of ingredient is it? Like, is it sugar? Is it flour? What's it going to do to our recipe? Because at the end of the day, we're a manufacturing company that's trying to create a very consistent product with no control over our inputs. So it's not like I can go order more widgets or more like screws or bolts to make our end product. At the end of the day, our customer really wants really good organic compost. And so in the spring, we're getting in a lot of grass. In the fall, we're getting in a lot of leaves. And so we've just got to be able to balance our recipes so that at the end of the process, the customer is getting the exact same compost. So we have to tweak recipes quite often, twice a week to hit that. So understanding what we're getting first and foremost is really important. And then mixing that recipe. So 30-to-1 carbon nitrogen, we want the bulk density is how dense that pile is. We want it light and fluffy so air will flow through it. We talked about moisture, so we want that 55%. Pile size, minimum to get heat is 2 cubic yards. Our piles are giant, so we're not too worried about that. And then there's software down here. We use a compost calculator. So for every batch, we put in all the recipe, and it spits out like what we're getting. And so we use that to calibrate and make sure that we're making the right recipe. So this is kind of what like a 28-ton load looks like. I should have put like a human or like a thumb up in there, but it's pretty big. And we have, as soon as it goes on the ground, so a big truck will come and dump all of this out. And the first thing we do is we have a whole crew of pickers, is what we call them. We should probably come up with a better name, but we really like at every stage we attack contamination. It's our number one challenge. And we fight very hard and we do an okay job, but there's a lot of opportunity to do better. The number one that kills us is glass. It's an absolute nightmare because another holy grail would be to like get the whole bottle. But if that bottle breaks, it's in shards, and you'll see through the system. We have some systems for vacuuming and sucking and getting things out, but glass, is small and dense, so it makes it through screens. It can't be vacuumed. And really, if a bottle ended up in your finished compost, like you would see it, like it glistens in the sunshine. So it is, of all of them, it is the most pernicious and the trickiest. But this is kind of what it looks like when it first shows up. Then this is the second stage. So it goes through our pre-processing line. And so we screen it a little bit. And then this crew here, and this is where, if you come out onto the site, you can really see what's happening. But these guys are picking out contamination by hand. This job is not awesome. I've done it plenty. But it's super important, and really getting it at the very beginning is super important. And so we pay these guys by the hour, and then they also get, guys and gals, and then they also get a per can bonus. So you see like this can here, they get extra pay based on how many of those cans they can fill a day. This is a large shredder. It's a high torque, slow speed shredder. Is also, you don't have a lot of scale there, but you could literally drop your car into that and it will shred it. So after stuff went across that picking line, it moves over here and gets put into the orange pumpkin, where it is shredded into a much smaller material. And that's really to aid the decomposition, right? So, a log is really hard to break down, but if we can shred it, and then it has a lot of surface area and a lot of available carbon is what we would call that. So the microbes basically have just a lot of surface area to like attach to and consume it. It's really good. So we actually prefer that shredded material, and it's also kind of bulky so that we can get a lot of airflow going in through the pile. So that's the second really important part of the process, is going through this shredder and breaking it down. And you can also see this little belt here is called a cross belt magnet, but it pulls metal out. So that's another chance. we'll see at every stage we're trying to pull contamination out. So when it landed, we pulled it, the pickers picked it. Now we're getting metal out, and we have a dumpster for metal. We make about $500 a month off of metal, and really, like, it's forks, spoons, knives. We have on site 4 40-yard dumpsters. About one a day gets picked up, so it's a lot of garbage. And we're in Dallasport, so our garbage goes to the Roosevelt landfill, which is a little further out. And we have to do an annual survey of all, like, how much comes in, how much goes out. So last year we composted 54,000 tons, and about 1,400 tons was garbage. Stuff either leaves as product, or garbage, or metals recycling, or it goes back to the beginning, which we'll see. So those are kind of like the output streams, like product, garbage, recycling. Okay, so some other feedstocks, we're in a heavy ag area, so we get a lot of pears. So in the certain time of season, we'll get 300 tons a week of pears that are from cold storage or didn't make it on the packing line. They used to go to landfill, and so this is another great win, that we can save that, and it makes really good feedstock. So we love getting that. The other one is cherries. They're huge in our region. Again, we'll get 300 to 600 tons a week of cherries. It's crazy. These are like edible, and I mean, it's a little bit mind-blowing, but just fruit size is really important. A lot of the markets where they go, if it's not big enough fruit, they just don't get sold. So it's a bit of a heartbreaker, but we get a lot of fresh packed cherries that don't meet spec, and they all just like hit at once. So the ability to just take them at the time they need to go is pretty important. This is the spent grain from a brewery. That's from Freem. It's not very often we get it, because we'd like to see it go elsewhere, but we do get it. And then food scraps. This is like the dream shot of clean food scraps. There are some routes in Vancouver that are the cleanest food scraps I've ever seen, like totally awesome. So just another good feedstock. And then we talked about the liquid. So that's our straight tanker that we pick up beer waste in. And then we have a vacuum one that we can vacuum out as well. Great question. So composting is a dual revenue stream business. So we charge a tip fee for everything that comes in, and then we process the material, and then we sell the product. And our whole aim is to environmentally and economically incentivize people. So our tip fee is priced below the landfill. So we're trying to save our customers money, but we still need to charge in order to, like, all that processing, like the orange pumpkin and all the pickers and all that stuff just costs a lot of money. So we need to take the tip fee to cover a lot of the production costs for the product. This is a completed recipe. It's like super simple one for a backyard, but just kind of shows, like, typically a backyard would be 3 parts brown, 1 part green. That's kind of a really shorthand for carbon to nitrogen ratio, brown to green. And then we talked about temperature. So as long as we got that recipe right, we mix it up, everything's good. Temperature is sort of like the cake rising. So, if you got the recipe right, temperature will go up. This is snow. So, people ask us that all the time, like, there can be a foot of snow on the ground, and if you get within a foot inside the pile, it'll be as hot as it wants to be. So we always say, really, the weather doesn't impact the compost at all. It just impacts the people trying to do the composting, because we get hot, we get, cold, our machines get hot and cold, but the compost is usually pretty independent and runs on its own. So the next step, turning and oxygen, super important. Those are, recipe is the number one most important. Next would be oxygen and turning. This is how we used to turn in Tyler's backyard with pitchforks. So oxygen, this is our blower system. It's all like stainless steel, pretty complicated, but at the end of the day, kind of what we talked about. So it's temperature controlled. So we have wireless temperature probes in our piles. There's 16 of them out there, and they all talk back to this blower. And then from our phone or our laptop, we set the temperature that we want the pile. And so, I've got it set at 145, and then this fan will run until it hits that temperature. So if it's getting too hot, the fans will speed up. If it's, getting too cold, the fans will back off. And the other really cool thing about this system is it's what we call both positive, negative. So we can When we're turning on this air pad, so a giant air hockey table, right? We don't want to clog up the holes. So when we're turning and we're running equipment on top of it, we run it in positive. So we crank up the fans and it pushes the air up, out, like it would in air hockey. And it's 120-mile-an-hour nozzle speed. So it keeps the air holes from clogging. When we aren't turning, it goes to negative. So we flip a switch and it pulls the ambient air through the piles, and then it exhausts out. I think I have a picture of a biofilter. Nope. And it exhausts out through a biofilter that captures odor and VOCs and ammonia and any other gases that might be coming from composting process. So it's really important for being a good neighbor to capture odors and stuff like that. So anytime we're not turning, we're in negative and we're exhausting through a biofilter. This is turning. So it's a special turner that we use that allows us to turn without having any aisleway. So when we looked at that aerial picture, it was just big blocks of compost. And most other facilities have like little skinny windrows because they have to have a turner that can turn it. But with this piece of equipment that we both love and hate, it will turn the compost. And like I said, we turn the pad twice a week and we turn the curing once a week. So it's just same thing happens year round, as long as people aren't sick or it's not a holiday, but we try to keep to that production schedule. This is it all heated up with, you can see the flags in the compost. That's where the wireless temperature probes are. And this is, in the morning, it'll look like this if you come in and it's in positive mode. This is, a little bit of an overview. We talked pretty much about how this flows through, but it's just kind of everything's labeled in terms of what's what. So the final process, right? We've been on air for 28 days. We've stayed above 131 degrees. We've killed off all the pathogens and we've turned it twice a week. We've added water twice a week. So back to the turner, it has a water bar on it and it's injecting 300 gallons a minute of water. So that's how we get the water into the compost. It's been through the curing phase. And then the last thing is here, it's a screener. So we grab the material, it screens through, we do a 3/8 inch screen. And that separates the fines from the larger, woodier stuff. And the larger, woodier stuff is what we call the overs. And it goes through a vacuum system. So again, we're trying to get that contamination. So it vacuums off the thin film plastic. So that's a contaminant that we can relatively efficiently get off. So we have two heads on a vacuum and we actually have something called an air knife. So it kicks the plastic bags up and then we can suck it off the top. We have a metal separator, we have a rock separator, but the contaminants we can't really get, number one, again, is glass. And then number two is like dense. I'm just trying to look for an example on my desk. Here's one. Oh, even supporting the brand. Like a dense plastic like this, it can't suck up. It acts like a piece of wood. It kind of has the same density as it. So something like this would end up going back to the beginning of the cycle. And I would hope the pickers would get it, but they might not get this. So something like this could ride around the facility, for years if it didn't get picked every time it went back to the front. We hope it would get picked, but so we call it like high density plastic is also another challenge. It's just hard to classify and separate.
We have several questions in the chat. Is this a good time to ask them?
Great time.
Okay. Why do you both love and hate the turner?
Because we love it because it is very efficient. It moves 1,500 yards an hour. It can add water. It does all these great things. We hate it because it's constantly breaking. We say everything on it moves except the seat. And so we have to replace every year it's called the face. So all the flights, all the teeth, and all the chains, everything that drives it, it's about $70,000 per turner per year. And we used to have 4 to have one running at any time. And now we're down to having 2 so that one can run. So it's just it's a hot mess, but it's the only thing that does what it does.
How do you make sure your compost doesn't have seeds or weeds?
So the process is what ensures us against that. So weed seeds might come in, Roundup might come in, right? Somebody might have sprayed it on their lawn. So the time and temperature regime is shown to kill weed seeds. It's shown to break down hydrocarbon chains. So it can break down, like if there were oil in there, it can break down the chains in oil. So by staying above 131 degrees for that 3 days, and then what we're adding to it is all that turning and all the homogenization really helps us ensure that everything has been at that temperature and been broken down efficiently. Cool. I'll keep moving. So post screening, this is kind of the example of that vacuum system, the blue thing there, and you can see like the hoses going out. That thing is $175,000 vacuum, and it's filling up dumpsters all the time. So it just kind of shows like how important this is to us. And we always say like the back end is the worst place to get it. We want to get it the day one, when the truck unloads, but we're trying it every moment we can. So post screening, so we've gone through the whole process. We've screened. We've got 3/8" minus. We've got this nice product. So what we're looking for is like it should be cool. The ideal is it's within 10 degrees of ambient temperature. So the microbes, the thermophilic microbes, when there's a lot of food around, they're eating it and they're heating up that pile. If we've composted properly, once they've started to kind of eat everything, they will start slowing down and not generating as much heat. So if we've consumed, most of the available food, then there shouldn't be a lot of heat left in it. So we want to be, for a finished product, we pick it up, it should smell like deep and earthy. We want that same moisture, so holding together, and then we don't want it to be hot. Like if it burns you to the touch, like that compost hasn't cured for long enough. So it should be, plus or minus 10 degrees of ambient temperature. So one thing we do, so through that whole process, we produce, organic certified compost, and that's because of our time and temperature regime. That's how we can certify it, even though like weed seeds might come in or even Roundup might come in. We work with our organic certifier and they say, yep, you've met these time and temperatures. It's all automatically logged by our wireless temperature probe system, so that we're able to certify it with that. And we restrict a lot of our feedstocks. So those compostable bags that you saw us pulling out, those aren't allowed. So even if they're plant-based, compostable products come up a lot. And people are like, will you take this cup? Will you take this, that? Will you take this, whatever? And there's a whole long list, but number one for us, we can't take it because they're not allowable in an organic system. So even if it's a bio-based cup or a bio-based fork, like it's made by a synthetic polymerization process. And so we can't take it and we will pull it out. So if any of our pickers see it, they will pull those products out. So we really tell people to honestly save their money because those things are 4 times more expensive. And when they get to us, they will be removed. And then Oregon DEQ did a pretty extensive study on upstream impacts, and some of those products can have a higher embedded energy than even a plastic cup. So in some situations, it seems counterintuitive, but you might see a cup that says compostable, or you'll see a plastic cup, but actually a plastic cup used and landfilled might have a lower carbon footprint than a compostable cup. And it really it gets down to each individual product and stuff like that, but you can't blanket assume because something says compostable that it is environmentally better. And then another real big factor for us is identification. So you saw that pick line, and I should have embedded a video, but the thing is moving fast. Like we have people get dizzy and kind of pass out or like kind of lean left because they're following it, but like it's moving quickly. And so as fast as things are coming through, I can't like pull this cup up and be like, is it compostable? So, our team that's up there, they're pulling it. So if, whatever it is, they don't have the time or the ability to look through them all and see it. So, another reason is they're just going to get pulled. And that confusion, we always say it should be all or none. So if every cup that came through were compostable, then we'd probably be okay. But as long as there's a mix of some that are and some that aren't, it's too hard to manage. And the risk of letting plastic through is too great to do it. So that's, those are some of the reasons. Just identification is a big deal. The organic certification is a big deal. Embedded energy. So it's a real sticky wicket, but for us, it's just clean and simple to be like food only, let's keep it simple. The driver, when they tip my can and reject it, they can say like, oh, that's not food. It makes it really simple at every level in the value cycle. So anyway, finished compost, we mix it. We do a lot of custom blends for our growers. So we'll look at some of the markets, but we have this giant mixer so we can put in all sorts of special amendments and make higher end soil. So we have our organic compost, but we can go even up from that, which we'll talk about now when we talk about products and markets. So benefits of compost, I'm sure you guys are all probably pretty familiar with this. The one thing we kind of learned early on when we were selling into like large farms and stuff is a lot of them ask about NPK and sort of what the nutrients are, and they definitely have it. So our compost is about 2-1-1 on the NPK, but really the benefits are all these other things about adding organic matter and building soil biology and moisture holding and buffering pH. So it does have the nutrient and that's there, but it's really just the whole system of improving the soil and building the soil and building a more resilient soil. So that to us is the big major benefit. This is a typical lab test. So we, my partner's a mechanical engineer. He's sort of a data freak. So we test a lot. We test every month. And then we test feedstocks all the time. We're just always testing. You can pull out from this the NPK. The thing we're always looking for is pH. So our compost, it's a bit of a head scratcher. It's usually always, it is always 7 or above. And a lot of times it'll hit 8. So if you're using our product, it's a good thing to know. If you're going to grow blueberries in it, you would want to lower the pH. And there's, things you can add to lower your pH, but it's always going to be higher than neutral. And we don't totally know why, but typically compost produced this way is like that. Organic matter percent, dry weight basis. So that's 48. We're pretty happy with that. We want to be around, 50% is good. So that's really adding organic matter to the soils. And then the other one that we look a lot at is this carbon to nitrogen ratio. So we started at 30-1 and the microbes consumed the material. And so what it's done is it's brought the CN ratio down. So we really, at a commercial compost, you want to be below 15-1. And we're routinely in that 11-12-1. So that means, that helps tell us that, yes, this has been broken down. It's mature, it's safe to put in the plant. Because if it hasn't been composted down like that, that's where you hear about compost will take the nitrogen from the plant because it still needs some to keep breaking down. So if you see a compost and it's got a CN, a finished CN that's above 15-1, it's going to take nitrogen from the plant. So that's a really important thing. And another one is salts people would worry about. So anything, the units are always a little bit different, but 4 is a rule of thumb. We want to be below 4. And honestly, like when there are spikes, it's typically with commercial food waste. So like restaurants, think about all the salt in those foods. And so if there's a lot of commercial, like restaurant food waste, we have to really look at salts and make sure we're balancing that out. Compost, I always say, is like, it's not like eating a vitamin, it's like eating broccoli, right? So it's slow release. So that nitrogen, it's not all just one shot, especially farmers want to just like hit stuff with nitrogen. And this is, 25% of it goes the first year, 15 the second year, 15 the third year. So it's adding over time, which we really like. We sell into potting and container mixes. We do a potting mix. So this time of year, we're selling to a lot of people doing seed starts. And we make specific mixes for that. We do a lot of raised bed projects. So we mix, typically for new raised beds like this, we would mix it with soil, or if you have soil, a 1-to-3 ratio. We do a mix called a ready to grow, which is probably not available in Vancouver right now, but it's designed for this, where you just dump into the bed. So it's already got the soil mixed and pumice and a bunch of other stuff. This is a nursery. Again, you want to mix it, especially like nursery or potted plants. And if you're buying potted plants and using compost, we always say, people are like, oh, should I fill the hole with compost? And we're like, don't do that, because that'll create this really nice, awesome environment. And the roots won't want to go past that hole because all the nutrients are in the hole. And so we always say, bring in that native soil and mix it. Only put 1/3 of compost in there, so that once the the plants come out of the container, they're going to want to punch past and get into the soil. Otherwise, you get that like containerized plant syndrome. This is a tomato place. So top dressing, we really recommend a top dress every year or two, put an inch or two down. We see a lot of that. New construction is a huge one. It's often overlooked. So when people are building new houses, they have excavators and equipment running around and it's compacting that soil. And we always say you get one chance to fix it after construction. So if people can put in a ton of compost and till it in and get that, organic matter back and reduce the compaction, we're big fans of, right after new construction, when the equipment goes away, like get the soil in order before you plant whatever it is, grass or plants. We do a lot of bioswale mixes. So, new construction projects are recommending that for stormwater retention. It's one of our favorite things to do. We like hitting spec material and we can get the inches of water column draining in an hour, and it's pretty fun. And we like seeing that in new projects. Custom potting planting mixes. This is a farm in the Dalles, is amazing. It had 0.1% organic matter in the soil. I mean, it's basically dead. And they'd been growing cherries there for 60 years. And so they finally ripped it out. And so we put a lot of compost back into the same cherry orchards that bring us the cherries. It's cool because that stuff will just go in a tiny little circle. But building this soil back up also gets us super excited about like getting organic matter back in there. And so we apply compost. We have our own spreaders and tractors, and we rent them or we'll do it end to end for people. We love doing that. There's another cherry orchard in the Dalles. There it is, looking glorious in the spring. And that's us spreading in another orchard. More drone shots. This is one of my favorite. I'm getting close to the end, Shannon, now. The tree on the right had compost. The trees on the left didn't, and that was like 1 year apart. I mean, it's crazy. Like double the size. People are able to really reduce their water. So out here, irrigation can be hard in some places. So we often start with people, if they can't get good irrigation, like start with compost because it holds 50% of its weight in water. So it's a really great way to stretch somebody's irrigation budget is with compost. New plantings, always good. This is a composted wood material, which we love. It's a nice mulch. Vineyards, we sell a lot into there. Same thing, we have vineyard spreaders and we'll go spread. If you're looking for good vineyard recommendations, we can give some to you out here. We do bag a little bit. It's a little bit kind of fingers on the chalkboard because, it's basically wrapping our product in trash, plastic trash. So I don't love bags, and we're moving to this refillable bucket program. We're actually getting buckets that are saved from the landfill and then we're reusing them. So it's pretty new to us, but man, I hope if we gave this talk next year that we would be using all buckets and not bags, because the bags kind of kill me. But we understand that people need them and they're right for certain uses. And this is my last slide, Shannon. This is just impacts from last year. Just, oops, I didn't update the tons. We did 54,000 tons of compost, 35,000 yards of compost sold, 21 full-time jobs. And another cool like industry tick is typically versus landfilling, composting creates 4 jobs versus 1 job in a landfill. So another like on the triple bottom line, it's like it hits them all. Cool. Thanks a lot. Thanks for your time, everybody.